Let's look at how we make guesses. In most situations, your brain follows a very specific set of rules to decide what's likely and what isn't. Imagine a big glass bowl with 100 apples inside. 99 of them are red, and exactly 1 is green. If you close your eyes and reach in to grab one, what color do you think you're holding? It's reasonable to guess red. The odds are so high that assuming you've grabbed a red apple is just a safe, practical way to think. We do this all the time. If you check a weather app and it shows a 99% chance of rain for the day, you grab an umbrella. You don't worry about the tiny 1% chance of sun because your brain treats a highly likely event as a practical certainty. This is how we navigate the world. When a probability is high enough, we treat it as a fact we can act on. It's the basis of how we make reliable choices every day. Now, let's take that same way of thinking and apply it to a raffle with exactly 1,000 tickets. If we look at ticket number 1 by itself, its chance of winning is only 1 in 1,000. That means there is a 99.9% chance it will lose. Based on our earlier logic, it's reasonable to assume ticket 1 is a loser. If we look at ticket number 2, the exact same math applies. It also has a 99.9% chance of losing, so it's just as reasonable to assume ticket 2 is a loser. We can do this for every ticket in the grid. One by one, the math tells us each ticket, on its own, will almost certainly lose. Following this logic, we conclude ticket 1 loses, ticket 2 loses, and so do all 1,000 tickets. So far, your thinking is consistent. You've looked at the odds for each ticket and made the most rational guess possible. Watch what happens when we gather all those guesses together into a single group. If you believe every individual ticket is a loser, and you combine those beliefs, you end up with one final conclusion. No one wins the raffle. But we know how raffles work. Exactly 1 ticket must be drawn. 1 ticket has to win. The logical conclusion that no one wins directly contradicts the physical reality that one person will. Your brain is now holding 2 conflicting ideas. You've followed a path of clear logic to reach a conclusion that you know is impossible. This specific logical knot has a name: the lottery paradox. In philosophy books like this one, it's used to highlight a conflict, the tension between what is likely for an individual ticket and what we know must happen for the whole group. The core problem is that a highly likely event isn't the same thing as the absolute truth, even though we treat them the same way when we're deciding to carry an umbrella. When you look at 1 ticket, that tiny gap of uncertainty doesn't seem to matter. But when you stack 1,000 of those gaps together, they grow. Eventually, those small chances of being wrong add up until they guarantee that your collective conclusion is false. This is why making 1 safe guess works fine, but combining 1,000 safe guesses can break your view of reality. Next time you feel almost certain about something, remember the raffle. Are you looking at a single event, or are you stacking together a long chain of guesses? Real logic requires knowing where a safe guess ends and a fact begins. Because if you gather enough likely things together, eventually the improbable is going to happen.